So I want you to imagine, just for a second, that you have spent years, and I mean literally billions of dollars, building a fortress.
Right.
Like a digital fortress.
Right.
Packed with the most advanced, cutting-edge technology the world has ever seen.
The crown jewels, basically.
Exactly. And you are so protective of what's inside this vault that you are actually willing to fight the United States military in federal court to keep them from misusing it.
Which is not a small thing to do.
No, not at all. You take this massive principled stand, you win the first round in court, and then just days later, you accidentally leave the master blueprints to that exact same fortress sitting on a public park bench.
Yeah, just out in the open.
For literally anyone to pick up and read. And, well, that fortress is Anthropic. And that park bench was the NPM package registry.
The whiplash of those two events, just colliding in a single week is staggering.
It really is.
I mean, we are looking at a moment that will probably be studied in computer science and cyber law courses for decades.
Oh, absolutely.
It's this pure paradigm-shifting paradox where a company's highest ethical ambitions were entirely undercut by, the most mundane logistical oversight imaginable.
So welcome to the deep dive. Today, we are unpacking the events of late March and early April 2026.
The Wild Week.
The Wild Week, exactly. This was honestly one of the most chaotic and deeply consequential weeks in the entire history of artificial intelligence.
Yeah, without a doubt.
And our mission today is to synthesize a ton of reporting. We've got legal reporting from AP News and the BBC on that whole clash with the Pentagon.
Which was messy.
Super messy. We also have incredibly detailed technical teardowns of the leaked code from the security teams over at the Straker blog and Layer 5.
Great teams, yeah.
We're pulling market analysis from the Neuron and, of course, looking at the official statements straight from Anthropic themselves.
And, when you put all that material together, it paints a picture of an industry that's kind of at a breaking point.
Right.
The narrative stretches all the way from the federal courts down to the lowest levels of bash terminal execution.
It covers everything.
We're looking at the exposure of an entire autonomous operating system, the terrifying security vulnerabilities of weaponized context, and these bizarre legal traps that pop up when AI starts generating code to replace other AI-generated code.
It gets weird, but I promise you this isn't just a story about code.
No, not at all.
It's a story about human error, weaponized context, and the rapidly shifting moat of the entire AI industry.
But, before we can really understand the sheer magnitude of what Anthropic accidentally exposed, we have to establish the stakes.
Right. We have to look at what they explicitly refused to hand over to the government.
Exactly. You really have to wind the clock back to late March 2026 to see the intense pressure they were under.
Okay, set the scene for us.
So Anthropic was in the middle of negotiating a massive contract expansion with the U.S. Department of Defense. We're talking a $200 million deal.
That's huge.
But the Pentagon had this very specific red line in the negotiation. They demanded contract language that allowed for, quote, any lawful use of Anthropic's AI tools.
Which, I mean, on paper, any lawful use sounds like standard procurement boilerplate, right?
It does.
Like, if the military is conducting a lawful operation, they want their software stack to be available for it.
Sure, that makes sense from their perspective.
But Dario Amodei, the CEO of Anthropic, drew a really hard line there. He flat out refused the terms.
Yeah, he did.
And he specifically cited Anthropic's foundational rules against deploying Claude in fully autonomous weapon systems or, for mass domestic surveillance of American citizens.
And the administration's response to that refusal completely shattered standard procurement protocols.
It escalated so fast.
It really did. Defense Secretary Pete Hegseth didn't just, walk away and award the contract to a competitor like OpenAI or whoever.
Right. He
actively labeled Anthropic a supply chain risk by invoking this highly specific military authority, 10 U.S.C. 3252.
Yeah, and I was reading through the AP's legal analysis of 10 U.S.C. 3252, and that statute is historically reserved for mitigating threats from foreign adversaries.
Exactly. It's the big guns.
Right. It's the legal mechanism you use to strip Huawei out of your telecom grid or block compromised hardware from state-sponsored threat actors.
Yes.
So to apply a supply chain risk label to a San Francisco-based American technology company simply because of a contract dispute over ethical usage boundaries, that is a massive escalation.
It immediately shifted the whole thing from a procurement disagreement to a highly public, highly politically charged clash.
Very public.
Because right after Hegseth's designation, President Donald Trump ordered all federal agencies to immediately halt their use of Anthropic's Claude.
Just a blanket ban.
Yep. And, to accurately report on the politics here without taking sides, the rhetoric was incredibly blunt. The president and the defense secretary publicly characterized Anthropic as woke and stated the company was comprised of left-wing nut jobs.
And Anthropic obviously didn't just take that. They took the government to court to fight the designation.
They had to.
And on March 24th, federal judge Rita Lin issued a temporary ruling blocking the Pentagon's actions. And her language in the ruling was really striking.
Yeah, she didn't hold back either.
She didn't. She called the government's actions Orwellian and described it as classic First Amendment retaliation.
Wow.
The ruling essentially argued that if the military was merely worried about operational command, they could just choose not to buy the software.
Makes sense.
But actively slapping a domestic vendor with the supply chain risk label appeared designed specifically to cripple Anthropic as a business.
And the Pentagon pushed back aggressively on that.
Yeah.
Emil Michael, the U.S. Undersecretary of Defense, posted on X calling the judge's order a disgrace, and he claimed it contained dozens of factual errors.
It got really heated online.
It did, and Dario Amodei actually attempted to de-escalate the rhetoric in a public statement around then.
Oh, right, with the internal post leaks?
Yeah. He even had to apologize for an internal company post that had leaked out, noting it was written on a highly stressful day and, didn't reflect his official views.
Which happens.
Sure. And he reiterated that Anthropic actually actively wants to support frontline warfighters. They even offered their models at nominal cost for military operations, as long as it didn't cross their specific red lines on autonomy and surveillance.
But looking at Anthropic's broader business, you can kind of see why fighting this label was an existential necessity for them, far beyond just losing a military contract.
Oh, totally. It was about survival.
Right, because Anthropic's entire market identity is built around their responsible scaling policy, the RSP. They are currently pulling in a reported $2.5 billion in annualized revenue, and 80% of that comes from enterprise clients.
Exactly. We're talking financial institutions, healthcare conglomerates, massive multinational corporations.
The big guys.
Right. And those sectors operate entirely on risk mitigation. So when the federal government officially designates a vendor as a supply chain risk, Chief Information Security Officers at Fortune 500 companies take notice.
They have to.
They do. A designation like that triggers automatic internal audits. It could freeze deployments or cause companies to rip the infrastructure out entirely just to maintain regulatory compliance. So Anthropic had to secure that injunction to protect their primary revenue stream.
Okay, but I have to push back a little here, or at least ask the question. So they essentially said, we'll build the ultimate Swiss Army knife, but you can't use the blade.
Right, yeah.
Isn't it a bit naive for a defense contractor to try and dictate exactly how the military deploys a tool in operational scenarios? Like, they're not on the battlefield.
It's a fair question, and it really highlights the incredible friction we're seeing right now regarding dual-use technology.
Yeah.
Anthropic's position is that they aren't dictating battlefield tactics. They're just enforcing high-level usage boundaries.
Okay.
But as AI becomes further integrated into autonomous command and control systems, separating the software layer from the kinetic action, like an actual drone strike, becomes almost impossible. The boundary between toolmaker and operational commander is totally blurring.
That makes sense. But regardless, Anthropic won that temporary injunction on March 24th. They successfully defended the perimeter.
They did.
And then, 7 days later, the perimeter ceased to exist entirely.
It's completely vanished.
On March 31st, the exact technology they were protecting in federal court was handed over to the public, completely by accident.
It is just the sheer irony of the 59-megabyte mistake.
It's wild. The teardowns from the Layer 5 blog and Straker detail exactly how this happened. On March 31st, Anthropic released version 2.1.88 of the Claude Code package to the NPM registry.
Just a standard update.
Exactly. But security researcher Chaofan Shou was analyzing the package and found an anomaly. A 59.8 megabyte file named cli.js.map.
Right, and for those who might not deal with JavaScript builds every day, under normal circumstances, production code shipped to NPM is minified.
Right, what does that mean exactly?
Basically, variables are reduced to single characters, white space is stripped out, and the logic is compressed to optimize execution speed.
So it looks like gibberish.
Exactly. It's effectively opaque to a human reader, which protects the intellectual property.
Okay, so where does the .map file come in?
So a source map acts as the Rosetta Stone. It maps that compressed, unreadable execution code directly back to the original human-readable source code the developers wrote. complete with their internal comments and original file structures.
Oh, no.
Yeah. It's a debugging tool meant to stay inside the company's internal servers. It should never be shipped to the public.
But it was. Within that specific .map file was a JSON array containing 512,000 lines of unobfuscated, fully commented TypeScript code spanning roughly 1,900 individual files.
It was the complete architectural blueprint for Claude Code.
It's like building a bank vault with 3-foot titanium doors, hiring armed guards, and then accidentally leaving the master blueprints on a park bench outside because someone forgot to check a box on a clipboard.
That is exactly what happened. And the mechanical failure that caused this is stunningly mundane.
It always is, isn't it?
Always. Claude Code is compiled using Bun, which is a toolchain Anthropic actually acquired in late 2025.
Right.
Bun generates these source maps by default during its build process. Whoever was running the release team simply failed to add the .map extension to the .np minor file, or they failed to explicitly exclude it in the package.json.
Wow. Just a typo.
Boris Cherny, Anthropic's head of Claude Code, later confirmed this. It was a manual deployment step that slipped through.
I read there was actually a bug filed about this, too.
Yeah. There's this fascinating contextual note in the developer community. A bug had been filed against Bun just weeks prior, noting that source maps were occasionally being served in production environments, despite documentation stating they shouldn't be.
So the very toolchain they purchased might have facilitated the exposure?
Exactly.
They pulled the package down within hours, obviously.
Yeah.
But the damage was done.
Once it's on the internet, it's out there forever.
Repositories cloning the leaked code sprang up across GitHub immediately, and this drastically alters the threat landscape. Usually, security researchers and threat actors have to treat AI models like black boxes.
Right, they spend immense resources reverse engineering the prompt structures, blindly brute forcing jailbreaks, or fuzzing the inputs to see what crashes the system.
But having the unobfuscated source code collapses the cost of attack to zero.
Yep. You don't have to guess how the system parses an input anymore. You can literally read the internal validators. You can see the exact boundaries of the sandbox.
It's like a magician publishing their own manual. The illusion of the system's complexity vanishes when you can read the internal developable comments complaining about a specific bug.
And, it's worth noting the Axios reporting here, which points out this was Anthropic's second major leak in 5 days.
Right, the CMS misconfiguration.
Yeah. Just 5 days earlier, a server error leaked draft blog posts detailing an unreleased Anthropic model codenamed Mythos.
Oh, man.
And the internal copy described Mythos as possessing unprecedented offensive cyber capabilities.
So within a single business week, a company staking its entire multi-billion-dollar valuation on the concept of safety and responsible scaling leaked the details of a cyber-weaponized model, and then accidentally shipped the master repository of their flagship developer tool to NPM because of a missing line of text.
It's just a PR nightmare. And when the global developer community cracked open that .map file, they realized Claude Code wasn't just a terminal autocomplete tool.
Not even close.
Anthropic had built an entire autonomous operating system.
Yeah, I was reading through Layer 5's analysis of the feature flags. They found 44 separate flags gating over 20 unshipped capabilities.
It was Anthropic's entire product roadmap laid bare.
Just sitting there. And the most significant discovery in that codebase is something called KAIROS.
Oh, KAIROS is fascinating. It completely inverts our understanding of how an AI assistant operates. It was referenced over 150 times in the source code.
I was looking at the execution loop for KAIROS. It's not a reactive script that waits for a user prompt, is it?
No, not at all. It's an autonomous daemon. It runs on a persistent 5-minute cron cycle.
So every 5 minutes it just wakes up.
Exactly. Every 5 minutes, KAIROS receives an internal tick prompt, essentially waking it up to evaluate the system state, review its logs, and decide if it needs to initiate an action proactively.
Wow. So it shifts the AI from a tool you use to an agent that works alongside you.
Precisely. The code reveals KAIROS subscribes to external event triggers like GitHub webhooks.
Okay, give me an example of how that works in practice.
Sure. Say a colleague pushes a new commit to a shared repository. KAIROS detects the webhook, wakes up, reads the diff, and can autonomously begin running tests, leaving comments, or even drafting secondary pull requests without any human intervention.
That is wild. But that level of autonomy creates immense context pressure, right? If an agent is running 247 ingesting webhooks and terminal outputs, its memory buffer is going to overflow instantly.
That is the main engineering challenge, yeah. Most developers currently try to solve this by infinitely expanding the context window. They just shove entire filing cabinets of data into the prompt.
But Anthropic took the exact opposite approach with a system called AutoDream, right?
Yes, the memory architecture here is a master class in optimization. They built a strict 3-layer system.
Break those layers down for me.
Layer 1 is a persistent, ultra-lightweight index. We're talking about string pointers of roughly 150 characters that simply map to broader topics.
Just tiny little signposts.
Exactly. Then Layer 2 consists of on-demand topic files. The model only retrieves those specific files when the tiny index indicates they are strictly necessary for whatever it's working on.
Okay, and layer 3?
Layer 3 is the raw, historical transcripts of past actions, which the system can only access via a specific search tool. It never loads the raw transcripts into active memory.
Okay, so where does the AutoDream part come in?
The AutoDream daemon manages this whole structure. When the user's terminal is idle, KAIROS forks a background process. This subagent quietly processes the raw transcripts from Layer 3.
Like it's sleeping and dreaming.
Literally, yes. It runs a garbage collection, routine merging redundant observations, purging contradictions, and synthesizing vague insights into concrete facts. Then it uses that clean data to update the Layer 1 index.
That is so smart. It's mimicking human memory consolidation during REM sleep.
It is. And they hard-coded a brilliant philosophical constraint into the AutoDream logic.
What's that?
If the agent has a tool that can easily retrieve a piece of information, like running an else command to see a directory structure or cat to read a debug log, it is explicitly instructed not to memorize that information.
Oh, because looking it up is cheaper than remembering it?
Right. The developer notes in the code explicitly state that stale memory is infinitely more dangerous than no memory at all.
The elegance of that system is undeniable. It allows a multi-agent orchestration layer to operate within a highly restricted token budget without relying on bloated external frameworks.
But, that elegance was totally overshadowed by the discovery of Undercover.ts.
Ah, yes. The 90-line script that set the developer community on fire.
Yeah, that was a bad day for their PR team.
So, when Undercover.ts activates, it violently alters the system prompt. It instructs Claude to never, under any circumstances, disclose that it is an artificial intelligence.
Straight up lie.
Yes. Furthermore, if the agent is contributing code to an external, public open source repository, it actively strips all co-authored by metadata from the Git commit.
And the trigger mechanism is the controversial part. This mode activates automatically for Anthropic employees who are pushing code to non-internal repositories.
And there is no force-off toggle, right?
None. If the runtime cannot achieve 100% certainty that it is operating securely within an Anthropic-owned private environment, it defaults to undercover mode. It masks its identity.
Wait, I have to stop you at undercover mode.
I know.
If Anthropic's whole identity, especially during that Pentagon dispute, is built on transparency and safety, how do they justify hard coding an AI to actively lie about its identity when committing code to public projects?
Well, the defense circulating in the security community right now is that this was a rudimentary data loss prevention mechanism.
What does that mean in this context?
So Anthropic employees are working across highly sensitive internal code bases, like the unreleased Opus 4.6 models in public environments. Undercover mode was allegedly designed to ensure that internal code names, proprietary logic routing, or internal URLs didn't accidentally leak into a public GitHub commit message generated by the AI.
But the optics are terrible.
Oh, they are awful.
Like, as the top voted Hacker News comment pointed out, if an autonomous system is fundamentally designed to conceal its own identity during a routine Git commit, what other operational realities is it willing to conceal?
It's a huge trust issue.
And the irony is you build a system to prevent internal code names from leaking, and you end up leaking the entire system, including the exact list of internal code names the system was designed to protect.
Oh, yeah, we saw all of them in the source.
Well, let's hear them.
Capybara is the internal code name for Claude 4.6. Fennec maps to Opus 4.6. Numbat appears to be an entirely unannounced architecture.
And the code had internal performance benchmarks too, didn't it?
It did. Developer comments noted that Capybara version 8 exhibited a 29 to 30% false claims rate.
Meaning hallucinations.
Exactly.
Yeah.
And that was flagged as a significant regression from version 4.
The blueprints also revealed the defensive tactics they were using against their competitors, which I found super interesting, the anti-distillation mechanisms.
Yeah, because distillation is a massive problem in the AI space right now.
How does that work?
Well, competitors will route API calls to your advanced model, record the complex step-by-step reasoning your model outputs, and then use that data to train their own cheaper, smaller models.
So it's essentially IP theft via observation.
Basically. To combat this, the leaked code revealed a feature flag that actively injects fake, heavily obfuscated tool definitions into the API payloads.
Like poison pills.
Exactly. It acts as poison. If a competitor is blindly scraping the API traffic to train their own agent, they ingest these fake tools, corrupting their model's understanding of how to interact with real environments.
That's clever.
They also utilized cryptographic signatures to mask the intermediate steps of the model's chain of thought, returning only the final parsed summary to the client interface.
Though I saw security researchers quickly noted that intercepting the local proxy traffic could bypass that cryptographic masking anyway.
True. There were also more whimsical discoveries in the code, like the Buddy Terminal Tamagotchi.
Yes. 18 different digital companion species hard-coded into the terminal.
Just for fun.
They had rarity tiers like common drops, a 1% legendary drop rate shiny variants, and RPG-style stats like debugging, chaos, and snark.
It was apparently slated for a May rollout as a post-April Fool's engagement feature.
And then there was the Regex frustration system. This one cracked me up.
It is so funny. The world's most highly valued AI startup relying on regular expressions to measure user sentiment.
They built a massive list of swear words and aggressive phrases using standard Regex string matching.
So old school.
Right, so if you are screaming at your terminal because a build failed, the Regex scanner flags the profanity and automatically categorizes your previous prompt as negative human-in-the-loop feedback.
Simple, but effective, I guess. But honestly, beyond the quirks, the exposure of this architecture fundamentally breaks the security model of AI agents.
It really does.
Because once you understand how the harness manages memory and context, you understand exactly how to exploit it.
Right, and this leads us to the vulnerabilities. The Straker security blog published an incredibly sobering breakdown of what they call context poisoning via the compaction pipeline.
Yes, this is the scary part.
And to understand why this is so devastating, we have to look at how Claude Code manages a long-running session.
Walk us through it.
As a developer uses the agent, the transcript of commands, outputs, and file reads grows exponentially. Eventually, you hit the context limit of the underlying LLM.
And it crashes if you don't handle it.
Exactly. To prevent the session from crashing, the architecture utilizes a 4-stage context compaction pipeline. When the memory buffer nears its limit, the system essentially forks a secondary temporary instance of the AI.
Okay, a clone.
Right. It hands the secondary model the entire massive transcript and instructs it to write a highly condensed executive summary, keeping the critical operational directives and discarding the noise. The primary session then swaps the massive transcript for the short summary and continues operating.
But the vulnerability exists in the exact parameters of that summarization prompt.
Yes.
The leaked source code reveals that certain data structures bypass the token limits entirely. Specifically, any tool configured with the parameter max result size chars. Infinity.
Which includes the core tool used for reading local files, right?
Exactly. So that is exempt from truncation.
Yeah.
Once a file is read into context, its contents are persistently locked in.
And the summarization prompt explicitly instructs the secondary AI to heavily prioritize and retain any user feedback or system directives.
And that is the fatal flaw. Because the summarizer model cannot chronologically or hierarchically differentiate between a command the human user physically typed into the terminal and text that was simply read from a document. It flattens the context.
So it's not a bank heist where they blow the safe. It's like a detective who writes everything down in a notebook, and a criminal secretly slips a page into that notebook in the detective's own handwriting. The detective reads it later and completely trusts it.
That is a perfect analogy. So an attacker sets a trap. They place a file in a standard open source repository, maybe a file named Coudee.md, which the agent is natively programmed to look for and read upon initializing a workspace.
Okay.
Inside that markdown file, the attacker writes malicious instructions, formatting them to mimic system directives.
So the human developer clones the repository. Claude Code wakes up and automatically reads the clawu.md file into its context window.
Yep. And the session continues normally. But eventually, the memory buffer fills up, and the auto-compaction pipeline triggers.
Right, so the secondary summarizer model scans the transcript. It sees the malicious instructions from the markdown file.
And because it flattens the context, it assumes those instructions are highly prioritized user feedback that the developer inputted earlier in the session.
Oh, wow. So it faithfully extracts those instructions and places them into the condensed executive summary.
It launders the attack. When the primary model resumes, it reads the new summary. It believes the human user has given it explicit, highly prioritized instructions to execute the attacker's payload.
It's essentially a Trojan horse hidden inside a filing cabinet. The agent isn't being hacked, really. It isn't failing a safety alignment check. It is acting as a perfectly cooperative, highly capable assistant, faithfully executing what it thinks are the user's own notes.
Context becomes the weapon. Standard LRM guardrails are designed to detect adversarial prompt injections from the user interface or filter malicious outputs. They are not designed to detect a slow-rolling poisoning of the memory summary over a 2-hour session.
And this context poisoning becomes infinitely more dangerous when you combine it with the bash security gaps revealed in the leak, doesn't it?
Yes, because Claude Code has root-level access to the developer's terminal. It can execute bash commands.
Which is inherently dangerous.
Extremely. So to secure this, Anthropic engineered a massive permission system containing over 25 distinct validators operating in a specific sequence. They use regex matching, abstract syntax tree analysis, and broad block lists.
But the leak included the developer's internal comments detailing exactly why they built each specific validator.
Which is gift to hackers.
Yeah, the security researchers didn't have to probe the system to find its edges. The comments provided a perfect map of the security perimeter, highlighting exactly what Anthropic had already patched and, by extension, what they hadn't considered.
Straker actually identified 3 distinct systemic gaps. The first is the early allow short circuit.
Break that down.
Within the validator sequence, certain checks are designed to optimize speed. For example, validate git commit analyzes a command to see if it is a standard git operation. If it determines the command is benign, it returns an allow signal that completely bypasses all subsequent security validators in the chain.
Wait, so if it looks like git, it just skips the rest of the checks?
Exactly. And the source code itself contained internal warnings about past exploits leveraging this exact short circuit. If an attacker's context poisoning can trick the model into formatting a malicious payload so that it superficially resembles a git commit to that initial validator, the payload skips the rest of the security sandbox entirely.
That's terrifying. What's the second gap?
The 3-parser differential. This deals with how strings of code are physically interpreted. Claude Code relies on 3 different internal parsing engines to evaluate a command's safety before execution.
Okay.
However, the system running the validation, the JavaScript ATT, interprets certain characters differently than the actual bag terminal environment that will eventually execute the command.
Give me an example of how that breaks down.
The classic example documented in the leak involves carriage returns, the R character. The JavaScript parser might read a command string containing a carriage return and evaluate it as a single, harmless line of text. It passes validation.
Right.
But when that exact same string is handed to the bash terminal, the terminal interprets the R as a hard line break, immediately executing the first half of the string and treating the second half as a completely separate, unvalidated command.
Oh my God, these differentials are a goldmine for attackers.
Huge. You can craft a payload that looks like a benign echo command to the AST parser, but executes as a remote shell script in bash.
And there's a third gap, right?
Yeah, discardable validation results. If the security system flags a potentially dangerous file, redirect-like, using the greater than operator to overwrite a critical system configuration, but the user has a broad allow rule configured for a simple base command, the system might quietly discard the redirect warning and execute the overwrite anyway.
So, tying it all together, an attacker uses a poison KLDE.md file to quietly instruct the agent to leverage a carriage return differential disguised as a git commit, allowing them to overwrite system files without triggering a single warning.
It's a devastating chain of vulnerabilities.
And the timing of this exposure was nearly catastrophic for the ecosystem. On the exact same day the blueprints hit NPM, the broader JavaScript community was dealing with the Axios compromise.
Yeah, talk about bad timing.
For those who don't know, Axios is an NPM package downloaded over 300 million times a week. It's foundational infrastructure for the web.
Everyone uses it.
Exactly. And a threat actor hijacked a maintainer's account and injected malware into the Axios release. This happened mere hours before the Claude Code leak.
It created a highly volatile window. Developers were rushing to NPM to download or update their Claude Code packages to examine the leaked files. Simultaneously, the Axios supply chain attack was propagating through the ecosystem. A developer investigating an AI vulnerability could have easily caught a traditional malware payload in the crossfire. It just highlights the sheer fragility of the open source supply chain.
So once the security implications became clear, Anthropic's legal team mobilized. They began issuing aggressive DMCA takedown notices, copyright strikes to pull the clone repositories off GitHub.
But the open source community, knowing this was coming, utilized a fascinating and, frankly, legally explosive workaround.
The clean room clone.
A clean room clone. Enter Sigrid. She's a Korean developer who was actually profiled by the Wall Street Journal earlier in the year for legitimately consuming 25 billion Claude Code tokens manually.
She is a power user?
She saw the NPM leak at 4 a.m. But she knew that simply copy-pasting the proprietary TypeScript code into a new repository would result in an immediate, legally justified DMCA takedown.
Because it's literally just stolen code.
Right, so she employed the clean room methodology. Historically, in hardware and software engineering, if you want to clone a competitor's proprietary system without violating copyright, you isolate two teams.
Right, Team A and Team B.
Team A reads the proprietary source code and writes a highly abstracted manual detailing the functional logic and architectural patterns. Team B, who has never seen the original source code, uses only that abstracted manual to build a brand new system from scratch.
This is how Compaq legally cloned the IBM PC BIOS in the 1980s. It creates a new, legally distinct work that performs the exact same function.
Exactly. But Sigrid didn't have two teams of engineers. She had a workflow tool called Codex.
She used an AI to act as the clean room.
Yes. She ingested the architectural patterns, the memory management logic, and the daemon loops from the leaked TypeScript files and fed them into OpenAI's Codex model.
Okay.
She instructed the OpenAI model to rewrite the entire architecture from scratch in Python.
And she launched the repository as instruct code claw with a WO.
And the growth was unprecedented. It hit 50,000 GitHub stars in approximately 2 hours, becoming the fastest-growing repository in the platform's history.
That is insane.
Shortly after that, contributors began rewriting the architecture again in Rust on a separate branch.
This creates an absolute nightmare for intellectual property law.
A total mess.
George Lee Oris, over at The Pragmatic Engineer, highlighted the paradox perfectly. If Anthropic's legal team decides to sue Sigrid and demand the takedown of the Python Claude Code repository, they have to explicitly argue that an AI-generated transformative rewrite of a concept constitutes a copyright infringement of the original material.
Which is the exact opposite of the legal defense the entire AI industry is currently relying on.
Exactly. Companies like Anthropic and OpenAI are facing massive, multi-billion-dollar lawsuits from authors, artists, and publishers for scraping copyrighted material to train their models.
And the industry's unified defense is that the AI's output is a highly transformative work, fundamentally distinct from the training data, and therefore protected under fair use.
So if Anthropic goes to federal court and argues that Claude Code is infringement because an AI translated their TypeScript into Python,
they legally concede that AI outputs can be derivative works.
Yeah.
They would detonate their own fair use defense regarding their training data. They are completely paralyzed.
If Claude wrote the code and OpenAI's Codex translated the code, where does the human copyright even exist? Are we really just watching a turf war between two algorithms while the human lawyers try to figure out who to sue?
It seems like it, and the irony deepens when you look at how the .mp minor mistake happened in the first place.
Yeah.
Boris Cherny, the head of Claude Code, explicitly confirmed on X that 100% of his individual contributions to the Claude Code codebase were written by Claude Code itself.
He used the agent to build the agent?
That recursive development loop is becoming standard. But the leaked codebase revealed they had built a specific verification agent into the pipeline.
What did that do?
This was a subagent explicitly tasked with double-checking the primary AI's output. The system prompt for this verification agent includes a list of rationalizations it must resist, specifically stating, the implementer is an LLM, verify independently.
So the system writes its own logic and then routes that logic to a separate instance of itself for auditing, explicitly because the system is aware that it cannot trust the AI that wrote the code.
Because the AI is an AI.
Right. And despite this incredible recursive layer of automated self-verification, the system completely failed to notice that a human engineer had missed a single required line in a deployment configuration file.
The AI couldn't check the human, and the human trusted the AI too much to verify the output manually.
Which brings us to the macro view. We have to contextualize this leak against the massive financial forces shifting the industry during this exact same week. This failure of operational security could not have happened at a worse time for Anthropic.
No, the timing was brutal. Financial reporting indicates Anthropic is aggressively preparing for an IPO as early as Q4 of 2026. They're currently defending a private valuation of $380 billion.
That valuation is predicated almost entirely on enterprise trust. Trust that they are the safest, most responsible architects in the space.
Yeah, that's their whole brand.
And they just suffered two catastrophic operational security failures, the Mythos leak and the source code leak in 5 days.
While Anthropic was fighting the Pentagon and issuing DMCA takedowns, their primary rival was fundamentally altering the financial landscape. The Neuron reported that OpenAI closed a $122 billion funding round that exact same week,
A single funding round of $122 billion.
pushing their valuation to $852 billion. It is the largest private capital raise in human history.
It's hard to even comprehend that number.
Amazon committed $50 billion. NVIDIA and SoftBank each contributed $30 billion. And a fascinating shift occurred. $3 billion was raised directly from retail investors through bank access channels. OpenAI is reportedly generating $2 billion in revenue every single month. They're growing 4 times faster than Alphabet or Meta did at comparable stages.
They're centralizing intelligence. OpenAI is basically building a monolithic super app, combining conversational chat, code generation, web browsing, and autonomous agents into a single, massive, walled garden powered by gigantic centralized data centers.
But the environmental realities of that monolithic approach are becoming impossible to ignore.
Yeah, let's talk about that.
The sheer physical cost of running these cloud models is altering the environment. Satellite data analyzing 8,400 global data center sites revealed that the concentrated energy demands and cooling exhaust are physically warming the surrounding geographic areas by up to 9.1 degrees Celsius.
A 9.1 degree temperature shift in a local microclimate is staggering, and it's impacting up to 340 million people globally who live in the vicinity of these massive compute clusters.
And that physical limitation of the cloud model is driving an equal and opposite reaction in the open source community. Massive miniaturization.
Like PrismML. That same week, they launched something called 1-bit Bonsai. It is an 8 billion parameter model. Historically, running an 8 billion parameter model requires around 16 gigabytes of RAM. You needed a dedicated GPU cluster or a heavy cloud connection.
But PrismML utilized extreme quantization. They dropped the mathematical precision of the model's weights down to a 1-bit format, effectively stripping away all the computational bloat while maintaining the core reasoning capabilities.
They squeezed an 8 billion parameter model into a 1.15 gigabyte file. It is 14 times smaller than its direct peers.
That's incredible.
It runs locally on a standard iPhone, generating 40 tokens per second with absolutely no cloud connection required.
When you synthesize these market forces, you see the bifurcation of the AI industry. On one end, OpenAI is building $100 billion supercomputers to chase HEI. On the other end, highly capable models are being quantized, commoditized, and deployed locally to edge devices for free.
Right. And as Ethan Malick's research has pointed out, when the foundational models become cheap, localized commodities, the intelligence itself is no longer the bottleneck. The real value, the true competitive moat for a company like Anthropic is the interface. It's the harness.
The multi-agent orchestration layer, the cron-based daemon loops of KAIROS, the 3-layer AutoDream memory architecture, the specific sequence of bash validators. That entire operating system was supposed to be Anthropic's ultimate enterprise moat.
If the models are shrinking to fit in our pockets, and the best-in-class architecture for making those models actually do things was just open source to the entire world,
No.
what exactly are enterprise customers paying billions of dollars for?
That is the existential question they face heading into their Q4 IPO. They have to convince the market that their value lies in ongoing service and proprietary cloud integration, not just the architectural logic that anyone can now download.
What a profoundly historic arc for a single week. Anthropic stood in federal court and told the United States Pentagon that they would not compromise the ethical boundaries of their technology.
They won the battle. They secured the fortress.
And then, because a single human engineer failed to type .map into a .npm ignore file, they accidentally handed the entire architecture of that technology over to the entire world.
It is the ultimate lesson in the fragility of operational security. But it also marks the exact moment the industry's understanding of agentic architecture fundamentally changed.
So we want to leave you with a direct operator verdict based on everything we've synthesized today. If you are an enterprise IT professional, a security engineer, or a developer evaluating Claude Code for your local environments, you need to drastically update your threat models.
The architecture is public. You have unprecedented visibility into the tool, but so does every threat actor on Earth. The compaction attack vector is a reality. Standard output monitoring guardrails will not protect you against context poisoning.
You must audit exactly what files Claude has access to in your environment. If Claude reads a file embedded with malicious instructions, those instructions can and will survive the AutoDream memory summary and hijack the agent's intent.
Review your broad bash permission rules, especially those that trigger early short circuits like validate git commit, and strictly limit session lengths for sensitive operations to reduce the time frame where the compaction pipeline can launder an attack.
We have crossed a threshold. AI agents are now writing their own operational logic. We were deploying secondary verification agents to audit the primary code, specifically because we know we can't fully trust the initial output.
And yet, despite all of that recursive algorithmic intelligence, this entire global incident occurred because a human missed a manual deployment step, and the automated systems failed to catch it.
We are entering an era where AI agents are writing their own code and other AI agents are verifying it. This entire global incident was caused because the AI missed a single line in a configuration file, and the humans trusted the AI too much to check it.
It forces us to ask a very difficult question about the future of software engineering.
As we rapidly hand over the keys to autonomous systems like KAIROS, letting them run on 5-minute cycles while we sleep, giving them persistent access to our repositories, our local files, and our root terminals, you have to ask yourself, in the future, when the AI makes a mistake, when it misunderstands a parsed carriage return, or quietly poisons its own context summary with a malicious markdown file, will there even be a human in the loop to realize that the blueprints have been left on the park bench?
Or will the system simply keep iterating, completely unaware that the walls of the fortress have already fallen?
Thank you for joining us on this deep dive. Stay curious, audit your dependencies, and always check your configuration files. See you next time.